In this tutorial, we will build a thermal model of a cylindrical lithium-ion battery using a 2D axiometric geometry. We start by setting up the model wizard. Here is exactly what we'll be covering in our tutorial today to construct this thermal model step by step. First, we'll tackle the model wizard and geometry setup. Then, we'll move on to global parameters and local variables. After that, we'll be setting up temperature probes, followed by adding materials to components. Finally, we'll configure the lumped battery interface and finish up by defining the cell equilibrium potential. Section 1. Model wizard and geometry setup. It is absolutely crucial to start with a clean slate here to properly define our physical space before adding any physics. From the File menu, choose New. In the New window, click Model Wizard. In the Model Wizard window, click 2D Axisymmetric. In the Select Physics tree, select Electrochemistry, then Batteries, then Lumped Battery, click Add. Still in the Select Physics tree, select Heat Transfer, then Heat Transfer in Solids, click Add. Click Study. In the Select Study tree, select General Studies, then Time Dependent. Click Done. In the Geometry toolbar, click Insert Sequence and choose Insert Sequence. Browse to the model's Application Libraries folder. Double-click the file. In the Geometry toolbar, click Build All. Click the Zoom Extents button in the Graphics toolbar. In the Model Builder window, under Component 1, click Geometry 1. The geometry now shows the battery can, the active battery material, and the mandrel. Section 2, Global Parameters and Local Variables. With the geometry in place, let's transition smoothly to setting up the rules of our simulation by importing our predefined parameters. In the Model Builder window, under Global Definitions, click Parameters 1. In the Settings window for Parameters, locate the Parameters section. Click Load from File. Browse to the model's Application Libraries folder. Double-click the file li_battery. In the Home toolbar, click Functions and choose Global, then Waveform. In the Settings window for Waveform, locate the Parameters section. From the Type list, choose Square. In the Period text field, type Cycle Time. In the Home toolbar, click Variables and choose Local Variables. In the Settings window for Variables, locate the Variables section. In the table, enter the following exactly. For name, type IAP. For expression, type lb.i1c times 7.5 times wv1 of t times t less than 1500. Set the unit to A, and for the description, type applied current. Section 3, Setting up temperature probes. Now for a nice mini achievement. We are going to set up specific domain probes to carefully monitor the thermal behavior throughout the simulation run. In the Definitions toolbar, click Probes and choose Domain Probe. In the Settings window for Domain Probe, type Mean Temperature in the Label field. In the Variable Name field, type Mean T. Locate the Source Selection section. From the selection list, choose Active Battery Material. Locate the Expression section. In the Expression field, type T-T init. Click to expand the Table and Window Settings section. Click Add Plot Window. Right-click Mean Temperature and choose Duplicate. In the Model Builder window, under Component 1, Definitions, click Mean Temperature 1. In the Settings window for Domain Probe, type Max Temperature in the Label field. In the Variable Name field, type Max T. Locate the Probe Type section. From the Type list, choose Maximum. Right-click Max Temperature and choose Duplicate. In the Model Builder window, under Component 1 Definitions, click Max Temperature 1. In the Settings window for Domain Probe, type Min Temperature in the Label field. Section 4, Adding Materials to Components. In the Home toolbar, click Add Material to open the Add Material window. In the tree, select Built-in, then Steel AISI 4340. Click Add to Component in the Window toolbar. In the Home toolbar, click Add Material to close the Add Material window. In the Settings window for Material, locate the Geometric Entity Selection section. From the selection list, choose Battery Can. In the Model Builder window, under Component 1, click Lumped Battery. In the Settings window for Lumped Battery, locate the Domain Selection section. From the selection list, choose Active Battery Material. Locate the Operation Mode section. In the IAP field, type IAP. locate the battery settings section. In the Q cell 0 field, type Q_bat. In the SOC cell 0 field, type SOC_init. Section 6. Defining cell equilibrium potential. We've reached the final major setup phase, defining exactly how the cell's equilibrium voltage responds to temperature changes. In the Model Builder window, under Lumped Battery, click Cell Equilibrium Potential 1. In the Settings window, locate the Open Circuit Voltage section. Click Clear Table. Please remember, you must strictly clear the table first before attempting to load the initial open circuit voltage data. Once cleared, click Load from File. Browse to the Application Libraries folder and double-click lip_battery